Hey, it's your teacher Jay, Professor J, Mr. J Johnson, and I'm back. And today we're going to be talking about adding and subtracting fractions. Now I'm going to try to hit both of these in this one video, but if it gets a little long, I'll chop it, make a separate video for subtracting fractions. That's standard 4.3e. I hope you guys are doing well. If there's anything wrong, if there's anything going on with you guys, even if you're not my student, remember you can write in the questions box below. If you're not one of my students, make sure you include your email. It's Mr. J. Here we go. So let's see. Let's say Cindy goes to the store and she wants to buy 2 6 bag of apples. Okay? But she already had 3 6 bags of apples. This is the very simple type of adding fractions questions. It looks a lot like when we were composing fractions. You just add these straight across because the denominators are the same and you'll get 5 6, just like so. So there's nothing more to it when it comes to that. Now, I will say this. I wrote PSP here because we do use problem-solving plans when we're working out adding or subtracting fraction word problems if they have no picture, right? Most of them do, but if they don't, you want to make sure you use that plan, because even though we're not adding, subtracting, multiplying, or dividing whole numbers or decimals, we are still trying to determine what operation to do, and therefore a problem-solving plan really helps out a lot. I'm not going to cover a problem-solving plan in this video. I'll put a link below for the problem-solving plan video if that's something you want to look at. If you want to skip through part of the video, I talk a little much at the beginning, but it's there if you need to look at that. We're just going to focus on how to do the strategy. So we have 3 6 plus 2 6 gives us the 5 6. Well, let's say she went to the store, and here are the more tricky questions, and she actually wanted to buy 1 3 6. She already had 1 3 6, bag of apples at home, and she wanted to buy 5 6 bag of apples. How many bags of apples will that be in total? So this is what we need to do. There's a couple ways to break this down. I'll go through some that I taught in class a little bit, and then I'll talk to you about ones a little simpler, a little quicker that we can work on. So we have 1 3 6, and then we have 5 6. Well, the 1 3 6 is pretty straightforward. All you would do is you would take this number here, and you could actually draw a picture of it using a fraction bar. So that's 1 whole, and then we would be able to put our 3 6 here. I shade in my 1 whole. I can shade it like this because I'm adding. Okay, if I'm subtracting, I need to break these up. And then I have 3 6, so we'll do 1 2 3 4 5, and we'll shade in 3 of them. Now that's the first number we have here. The next thing we would have to do is just add 5 6 to that. Well, we have 3 6 that can be added here, so we would shade 1 2 3. We have to make another one. We did 3 4 5. So now we can see that we have 1 2 wholes and 2 6. So our answer would be just like this. Now you might ask, well, what happens if this is a bigger number? Okay, we'll get to that in a second, but let me show you another strategy for doing the same thing here before we get there. Another great way to do this is a number line. Okay, this one, just like the one before, works great for adding and for subtracting fractions. If I'm doing 1 3 6, I could go ahead and put this here. Say that's 0, that's 1. We'll say 2 is here, and we'll say the whole number 3 is there. So we put our whole numbers here. We look at our denominator to tell us how many pieces to divide the fraction into. In this case, it's 6 pieces, which means I'm going to put 1 less than that in between. 1 2 3 4 5. That way when I count up, I'll get 6. 1 2 3 6 4 6 5 6 6 6, just like that. So I'll do that in each one of these. Now I've been writing lines like this for a long time. I've done it 1,000 times, maybe literally. So because of that, my lines look like they're pretty evenly spaced. But if when you make yours, your lines aren't perfectly spaced, or when you make your fraction bars, the bars are not perfectly created, for this, it doesn't really matter. It just matters that you put the right number of bars there or the right number of number line ticks, okay? So in this case, we're going to find the first number, which is 1 3 6. We have 1, and then we're going to count the 3, 6. That's 1. I should make that a little bigger. 1, and we're going to count 1, 2, 3, 6 right here. So we identified the first number, 1 and 3, 6. Now, this is a great way to do this. The next thing I would have to do is add the 5, 6 to this. So I would say 1, 2, 3, 4, 5, 6. We can see that we still ended up with 2 and 1, 2, 6. We still ended up with 2 wholes and 2, 6, just like we did here. This is just a different way to find that answer. Now, to get back to the question that I mentioned before, well, Mr. Johnson, what happens if this is a large number? Let's say Cindy wasn't just a girl that just goes to the grocery store. Maybe she's a girl that owns a restaurant and she actually sells fruit bowls. So when she goes to the store, she doesn't need 1 or 5, 6 bag of apples. She needs an enormous amount of apples. So let's say she already has 22 and 3, 6 bag of apples, and she actually wants to buy 15 and 4, 6 bag of apples. So you're dealing with big numbers here. So because of that, well, they're not big, but relatively they're big to the previous number we did. The reason why this is important to look at is because I would not make 22 bars and then add another 15 bars and 4, 6 bars. I wouldn't do all that, right? It would take too much time. A number line is something that could potentially still work for us. You would just need to zoom out a little bit on your number line. But a great way to do this without doing either of those is to actually just set it up as an addition problem, but you have to know some things going on here. So what I would look at is this here. I would look at adding not my whole numbers first, but I would actually look at adding my fractions first. So if I had to add 3, 6 and 4, 6, that's pretty simple to do, right? 3, 6 plus 4, 6. When I see 3, 6, and 4, 6, that allows me to just add them. I have 3 plus 4 is 7, 6. That's great. The only thing that we need to do here is actually change the 7, 6 into what's called an improper, a mixed fraction, okay? How do I change this improper fraction to a mixed fraction? Well, it's very simple. What I'm gonna do is, there's a couple of strategies for this. One strategy that's really easy is to just draw a picture of that, right? So I could then make a bar model out of this, okay? I have 1, 2, 3, 4, 5, 6, 6, but I need 7. So I have to make another bar here and shade in that last one. So I have 7, 6. So the way I would translate this from 7, 6 is to 1 whole and 1, 6. There's another way to find this where all I would do is if I see this is the 6 in the denominator, I would just subtract 6, 6 like so. And that would give me 1, 6. So this 6, 6 is the 1 whole. So I would still get 1 whole and 1, 6, okay? If you have a question about that strategy, you're really interested in doing it that way, just write me in the questions, okay? But this right here is great. I have 1 and 1, 6. That was only adding my fractions. I still have 22 and 15 that need to be combined. So what I can do is I can take this 1 and 1, 6 and just put it to the side like so. And then I can just add my regular whole numbers. My whole numbers in this case were 22 and 15. I add these up, that's gonna give me 7, 3, and then I'll add them to the 1, 6, to the 1, and 1, 6, which will give me 38 and 1, 6. Again, we are going to end up splitting this video to 2 videos, but again, there's something really great here that I can do that looks a little bit different than the way I did all this, kind of jumbled up steps, and makes it a nice, smooth steps. Watch this. Again, I didn't show you guys this in class because a lot of students, they end up messing this up if they don't pay attention to all the steps, okay? So instead of writing it like this and leaving it this way, when I'm presented with this, I could actually stack these numbers on top of each other. Add the whole numbers on one side, fractions on the other. What will happen is I will still do the addition of these fractions here, just like we did before. I will still get the 7 6. I will still be able to change that 7 6, because 1 whole and 1 6, into 1 and 1 6. It's just that now I know that this fraction piece will be left here, 1 6, and this whole number piece of the whole number 1, I'll just add it to the front here. So instead of that being 22, I can make it 22. I can put a plus 1 here to know that I have 23. So it's 23 plus the 15, excuse me, is going to give me 3, 8, 38. 38 and 1 6. When I learned how to do fractions, this is the way that I learned how to do it. It's really a quick way. So if you're really comfortable with the numbers, go ahead and do it this way. If not, try using your number line, try using your fraction bars. Just when those numbers get really big, understand that maybe I should just use the number line of fraction bars on the portion of the problem that I can't understand myself. What do I mean by that? I mean that instead of using this model, if I really just don't get it, no matter how much I try, I could just add these two parts right here using my number line. For example, 0, 1, we'll just say 2, and we'll say we have 1, 2, 3, 4, 5. Okay, we have 3, 6, and then we have 4, 6. So we count 1, 2, 3, 4, 6. That's 1 whole and 1 6. You see how we still got 1 whole and 1 6? When I see that, that lets me know that, hey, I can go right here to taking this 1 and 1 6 and adding it to the sum of 22 and 15. I'm still going to work it out and get 38 and 1 6. But this is a different way where you can kind of mix these strategies together and come up with an answer. I hope that was great. I'm going to make another one on subtracting fractions. I'll put the link below, along with the problem solving plan and the question link. If you have any questions, hit me up on that question link, and I hope you're doing well. Peace.